So welcome to the December training for NEMSIS, last training of 2025. Thank you all for coming. I cannot believe, I was talking to Josh about this before we started here a little bit. I cannot believe how quickly this year has gone past. Every once in a while, I'll think in July about the and look forward at the calendar and see the December training and think to myself, well, it's not that far away. And of course, here it is. So today, like I said, it's the December 2nd, 2025. If To put in a little bit of a plug for some of the stuff that I take care of here at NEMSIS, if you want to be alerted about this and other goings on from the NEMSIS TAC, you can find us on pretty much every major social media platform. Look for NEMSIS TAC, TAC, and you'll find information about trainings like this, uh, 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 research papers that use NEMSIS data, when there are job openings and stuff like that. All the latest, greatest information comes out on those channels. Also on our YouTube channel, where this training will be posted usually by the end of the week, and where all of our trainings and V3 calls and other helpful videos are posted. Also looking for NEMSIS TAC. You can also join our newsletter if you go to the nemsis.org webpage. Scroll to the bottom of the page. There will be a button there that says open a help desk ticket. One of the requests that you can open a help desk ticket with is to join the newsletter. And even then, there will be some options as to what information you want to be sent from the NEMSIS TAC. So take advantage of all of those things so that you can be apprised of all the cool goings on here. But for today, I'm really excited about this. If you hear the word schematron and you're not quite sure what it is, when I first started with NEMSIS, I heard schematron and I thought, wasn't that one of the bad guys from the Transformers cartoon? And it's not, surprisingly enough. But what is it, and what's the difference between schematron and the XML schema? Uh, if you don't know already, you're going to know, because our awesome EMS consultant, Joshua Legler, is going to be here to explain the basics and what the differences are and why NEMSIS uses both and how it all works together. So if I could get a big virtual round of applause for Josh, and thank you so much for taking the time today to explain this to us. I'm excited about this, and yeah, you can go ahead and take it away.
Thanks, Chris, and good morning or good afternoon, everyone. Thanks for joining the training today. And yeah, that's just like the one kind of personal hope I have for the training today is that everyone who is attending today, by the end of this training, you will know when to say the word schematron and when not to say the word schematron. You'll know exactly what it refers to and what it does not refer to. So that's my personal goal. We're going to talk about data validation in the NEMSIS XML standard using both XML schema and schematron. And I'm going to help you uh, figure out the difference between XML schema and schematron. As we go through the training, I'll be watching the chat. I welcome questions or comments there. Also, I welcome you to raise your hand in Zoom. If you know me, I'm happy to take questions or comments throughout the presentation. If you bring up a question that I think I'm going to answer later, I'm happy to tell you so. But I like to be able to take care of any lingering questions as we go, so that you can get those answers and not forget the question. So here's what we're going to look at today. First, a refresher on the basics of extensible markup language, or XML. And then we'll go into validating XML data using something called XML schema, and then validating data using something called schematron. And we'll understand the differences between those two tools. And then lastly, just some stuff, how the NEMSIS TAC publishes resources that help you figure out the validation constraints on NEMSIS data in the data dictionary, and schematron schemas that are published both nationally and by states. So we'll finish with those. All right, so let's jump in, kind of a basic on XML. So the NEMSIS standard is XML based. and that stands for Extensible Markup Language. So it's a language that defines rules for encoding data using something called markup. Markup is essentially putting tags around the data. So you've got data, and then you've got stuff around the data, in other words, markup, that tells you what that data is and gives the data meaning. So NEMSIS XML data look like this. This is just a little snippet from the EMS data set in NEMSIS, which is for patient care report data. And so you can see in here these tags. We have the EMS data set document itself, and then we have a header and a demographic group, and we have D agency 1, 2, and 4, the end of the demographic group, and then we start into the patient care report in this file. And so all that stuff in color you see there is the markup that gives meaning to the stuff in black, which is the actual data. That's XML. And software, EPCR products, they take information that's entered by EMS personnel and they transform it into XML when they export the data. So it ends up going like this. So you might have a PCR data entry screen. An EMT or paramedic is using that. They're entering the patient's first, middle, and last name in these 3 different boxes. Okay, so the software then is generating the XML export that it's going to send to some other software system. And it's using that markup so that the receiving software system knows what the data means. It knows that Doe is the patient's last name because it's in this tag called ePatient.02, and NEMSIS has defined that to be the patient's last name. So that's how it gets from kind of what the EMT sees to that XML output that goes to other systems. Well, XML data can be validated, and this is one of the core strengths of using XML. So NEMSIS 3 data are validated using 2 types of validation technologies, I guess you could say. One is called XML Schema, and the other is called Schematron. Both of these are international standards. The XML Schema is what's called a grammar-based validation, and Schematron does what's called rule-based validation. So grammar-based validation, think of it like grammar for the English language. It tells you how you can structure a sentence, or in our case, some data about a patient care encounter by EMS, how you can structure that in, following some rules, right? So you have subject, object, verb, you have a period, you have commas, whatever, all the stuff that can be allowed. That's the grammar. And that's what XML schema does. But then Schematron can come along and it can do some rule-based validation. And just like in the English language, you might say, I went to the store, and that's grammatically correct. You could also say the store went to me, and that's still grammatically correct, but it might not actually make sense. So with Schematron, we can do these rule-based validations that say, yeah, you got a subject, object, verb, but stores can't move. So that doesn't make sense. So that's the difference between grammar and being able to just define rules about what's not allowed. Okay, so let's go into XML schema here. Here's how XML schema validation works. First, the software, the ePCR software that's generating the XML, it checks an XML document to make sure it is what's called well-formed. Well-formed means that it adheres to the basic rules of XML. So all of the elements are in those markup tags that I showed you. Every beginning tag has an ending tag with a slash in it, and so on. So if we look at this example, this XML document is not well formed. We see it's a document. It has a title tag, and there's a slash title tag to end that element. Then we have a paragraph tag, and then there's no slash paragraph at the end there to end that paragraph. So this is not a well-formed XML document. This would be considered not well-formed, not valid. So that's the first step. Is it well-formed? And that's just following the basic rules of XML. So this is nothing specific to NEMSIS. And any XML validation tool out there That's the first thing it's going to do is see if the document is well formed or not, completely independent of any NEMSIS constraints. Okay, so second, if it is well formed, then the XML document is checked to make sure it's valid. And valid means that it conforms to something called a schema. The schema says this is what a fill in the blank document should look like. So in our world, the NEMSIS schema says this is what a NEMSIS document should look like. And we use in NEMSIS a schema language called XML schema. So this can be a little confusing because it sounds so generic. We are using an XML schema language called XML schema, and that is the most popular XML schema language out there, but there are others. And so an XML schema definition is abbreviated as XSD, and you've probably heard that XSD thrown around a lot in the NEMSIS world. That is the NEMSIS XML schema definition. Those are the files that actually describe the XML schema that NEMSIS uses. Okay, so an XML schema defines rules for what data an XML document can contain and how the document is to be structured. And an XML schema itself is written in, guess what? XML. It's an XML document itself. Here's an example. So this XML document that you're looking at here is again an EMS dataset XML document from the NEMSIS standard. And I'm showing you just a couple tags right at the very top of the document. The first line indicates that this is supposed to be an XML document using XML version 1.0 and using a particular character encoding, UTF-8, which is a Unicode encoding and covers like all the languages in the world, all the different characters you could potentially have in those languages. And then it has a tag called EMS dataset, and it tells us this XML NS or namespace is in nemsis.org. So this document belongs to the NEMSIS namespace. And then it's got this tag here, schema location, and it's got for the NEMSIS namespace, nemsis.org, same as what's up here. Whoops, use my mouse over here. nemsis.org, for that namespace of nemsis.org, it's telling us where the schema is that this document claims to be compliant with. So this document is telling us itself, hey, I'm an XML document and I claim to be compliant with this schema right here. You can go get this schema through a web request and you can validate me to figure out if I really am valid or not. So that's a URL that references a spot on the NEMSIS website where the EMS dataset schema file can be retrieved. So an XML validator can go get the schema from that URL, and then it can validate this document. And what's cool about this is like any XML validator. So, like if you have Microsoft Visual Studio Code and you've got the XML extension installed in it, you open up an XML document, it's automatically going to go grab that schema from the NEMSIS website, and it's going to show you a list of potential errors down at the bottom of your window saying, hey, here's what's wrong with this document, or everything's okay. And so it's not like you need special tooling that came from NEMSIS or something. Any XML validator just knows how to do this stuff. So here is a little snippet from the actual XML schema itself. And you see it is written in XML, as I said. And this is a little snippet of XML schema that defines or declares a data element. This particular data element is the patient's first name. And what this schema is telling us is this element may occur 0 times, or it could occur once. It's named ePatient.03. So we can go find that in the data dictionary. It says nillable equals true, so that means this element could be empty. And then it says that it's got a restriction of string. So this element can be a string. And then it has a min length and a max length, so between 1 and 50. So it could be empty, but if it's not empty, then it needs to be at least 1 character long, and it can't be more than 50 characters long. And so this is just that little snippet that tells us what a patient's first name is going to look like in the NEMSIS XSD. So looking at an example, this piece of XML data is not valid in the NEMSIS schema because this long string that I provided here in ePatient03 is longer than 50 characters long. So if you were to open up this document in any tool that can do XML validation, it would go grab the NEMSIS schema, and then it would highlight this element and say, this is invalid, it's too long. Okay, so how does this relate to what software developers do in their ePCR systems? Well, they use the information from the NEMSIS XML schema to decide how to design their databases. And so, for example, they might make the patient's first name be a string of up to 50 characters in their database, since that's what the NEMSIS schema says. They don't have to do that. They could allow names up to 100 characters, but then when they export the data, they're going to have to deal with that. And so oftentimes vendors will follow the schema as kind of the guide for how they're going to design their databases and their systems. They also use information from the schema to build validation routines into their user interfaces at the time of data entry. So, for example, they might go ahead and put something in their UI so that if you type in a patient's first name that's longer than 50 characters, then in their UI, they're going to show you some kind of message that says, whoops, patient's name is too long. It needs to be no more than 50 characters long. So, excuse me. So that's how software developers are going to take what's in the schema, and then they're going to design their UI and their databases and all of that in their systems to try to implement and follow what the schema says. Well, other validation checks, maybe they can't do them kind of on the fly. So here's an example. Back in service time, that can't be empty. The schema says it can't be empty. But you need to allow the EMT to go all the way through their PCR, go to all the different places, fill it out. At the very end, they put in their back in service time. So the software might have to wait to flag this, or they might flag it as they go, but still allow you to continue on through the PCR and come back to it later to fix it. So those are the kind of design decisions that software developers end up making. All right, so even though the software tries to catch errors as early as it can, the XML schema is really the standard. So when it's time to finish a patient care report, or it's opened back up later and some edits are made, then the software transforms the PCR into XML, and then it's checked to ensure that it's both well-formed and valid. So we always have that standard, that gold standard we can rely on by getting it into XML and validating it. Whenever an XML document is transferred from one system to another, then the receiving system also checks that document to make sure it's both well-formed and valid. So the receiving system does not trust or rely on the sending system. It does its own validation on the way in, and that helps protect that receiving system from getting bad data. Okay, so let's recap what we can do with the XML schema. We can check that it's well-formed, adheres to the basics of XML. The XML schema can tell us where an element is within a document or where it should be, how an element is grouped with other elements together, such as vital signs, how many times an element can occur in a document. So you can only have one back in service time, but you can have lots of scene delays. Data types, such as strings, integers, decimals, dates, date time, or values from a defined list that says, hey, you have to pick one of these. Min and max values or min and max lengths on strings, and even pattern matching using what's called regular expressions. And so those can be quite powerful to say, these are the types of patterns that we allow for the data in this element. Karin, I see you have your hand up. We'll have Chris unmute you and go ahead.
Yes, thanks. Good morning, everybody. Thanks for this session, Josh. As you know, I actually know a lot about this from my time, various areas, 8 at the NEMSIS TAC. But I have a question. So when we take into consideration that the uh, NEMSIS 350 critical patch 6 and the NEMSIS version 351 critical patch 2 are have been released. Is it possible that a software company could deploy those schemas behind the scene to either an agency software or a state software that for states it would prohibit XML files coming in if a an agency hasn't transitioned to, for example, e-patient.25, the new sex element?
Yes. So the first critical patch that came out in the spring, in the XML schema, it added a data element. So, much like this one, so an excess element tag was added to the schema. It was called patient sex, or sex, I guess, just sex. And it had a min occurs of 0, so it didn't have to be there. And then it had a value list, which you don't see here, but it would have had a list of allowed values for male, female, and unknown. And I think it also allowed some pertinent negatives and not values. And so those were all defined in the schema. The key was that it had a min occurs of 0. And so that means that if you were sending data to a system and that system was using critical patch 5 or critical patch 1, the spring critical patch to validate data, well, if you didn't have ePatient.25 in the data, the receiving system was just fine with that because the schema said that element could be there, but it didn't have to be there. Well, then come fall or summer, I guess, the latest critical patch was released. And as you know, then the national EMS database decided to deploy that latest critical patch in November. And the latest critical patch, the only change it made is it took out min occurs equals 0 on ePatient.25. So then it meant ePatient.25 has to be there. It might be empty, might have a not value pertinent negative, but it has to be there. So then when the national database received data that didn't have that element in it, then it would reject it. And that's what it started enforcing in early November. So same thing goes for systems at other levels. So a state level system, the decision was available as to when the state level system would actually deploy that latest critical patch. And as soon as it deployed the latest critical patch, then it would start rejecting any records that did not have ePatient.25.
Okay, thanks for explaining that to me
Mhm.
and the others. I hope it provides guidance. Thank you.
Yeah, that was great. Well contexted question since it's so fresh in our experience.
Yep.
All right, so the XML schema does a lot, right? I showed you these are all the kinds of things we can do in an XML schema, but there's a few things it can't do. Mainly, it can't cross-check data between two different elements. So, for example, it can't say that the times are out of order or that they should be in a certain order. It can't say, unit notified date time, back in service date time, the actual values of these times have to be, one has to be greater than the other, anything like that. It can only define, grammar-based validation. It can only say what e times 03 should look like and what e times dot 13 should look like, but it can't say anything about what their values might be in relation to each other. Give me a second. So another example, it can't say that the number of patients it's seen should be multiple when you reported an MCI because those are two different data elements, and it just can't do those sorts of constraints. So enter Schematron. This is where the NEMSIS stack uses Schematron, which is also an XML schema language. So we've got XML schema, and then we've got Schematron. Both of them are schema languages. Schematron's the tool for catching what XML schema can't catch. The inventor of Schematron called it a feather duster to reach the parts that other schema languages cannot reach. Schematron can do everything XML schema can do. It's rule-based. We could write a bunch of rules that would say, after the patient's first name, then there should be the patient's middle name and then the last name, and the first name should be no longer than 50 characters and so on. We could do that, but it doesn't make sense to put something in a schematron that the XML schema has already been able to do. So we don't do that. We only use schematron for the stuff that XML schema can't do. A little side note here. So we see some states that publish their state schematron rules, and they'll say something like patient care report number is mandatory. So they write a rule that says it's mandatory. Well, that's great. The problem is the XML schema already says that patient care report number is mandatory. And so we've already got that constraint. We don't need to add it into a state schematron rule. It's just redundant. Okay, so here's the stuff we can do with schematron. We can check uniqueness. So for example, among all the crew members, only one of those crew members is the primary patient caregiver. It can check sequences. So all the odometer readings, they got to be in order. The arrive at scene reading needs to not be more than the left scene, than the arrive at destination. They can do calculations. So the GCS total needs to be the sum of the I plus the verbal plus the motor. And they can do conditional checks, like a blood glucose reading in vital signs should be recorded after a glucose administration in medications was performed. And we can check the timestamps and the different sections and everything and have that kind of a constraint. Just a second here. Okay. Schematron, guess what? It's also XML based. So a schematron schema is just an XML document itself. Once a PCR has been converted to XML to check that it's well formed and valid according to the XML schema, then it is checked against schematron schema. So here's how schematron works. This is a very boiled down example of a piece of a schematron schema. Primarily, schematron schemas contain patterns, rules, and asserts. So here we have a pattern, which would have an ID. Within that pattern, we can have multiple rules. The first rule that fires in that pattern is the only one that we look at when we're running validation. So any rules after that, the first one that fires, they don't even get looked at. The rule has a context. The context is written in something called XPath, which is a way of referring to the contents of an XML document. And the context tells us where to look in the document or where this rule applies. And then, oh, whoops, I made a mistake here. This line where I said role, that should be down on the assert, not the rule. Okay, so the rule has a context, where to look. If we find that context in our document, then we check all of the asserts in that rule. And I have just one assert here. The assert has something called a test, and this is a true-false condition statement. So you assert something should be true. If it ends up being false, then show this message in the validation results. Now, role should be down here on assert. I put it in the wrong place. That tells us if that assert, at what level of enforcement we should put behind that assertion if it fails. Is it fatal, which means we need to just stop and reject everything in this submission? Is it an error, which means the particular record that we found this in is not allowed, this patient care report or this demographic record? Or is it a warning which says, hey, something to be aware of, but we're still going to take the document. We're still going to consider it valid. So patterns, rules, and asserts. The context is really important, and then the test. So let's show an example here. So here's the schematron pattern for checking where we had a mass casualty incident, but they said that there was only one patient at the scene. So we have a pattern, it has an ID. We have a rule, and it has a context. The context here is the e-scene section of a NEMSIS patient care report, but only when that e-scene section has e-scene.07, which is mass casualty incident, equal to 9923003, which is the code for yes. So we're saying the context is going to be the e-scene section when a mass casualty incident is answered as yes. So on all the PCRs where mass casualty incident is not yes, then this rule will not fire, and this assert down here will not be checked. But when we do get a patient care report where mass casualty is yes, then we've got our context. It's the e-scene section, and we're going to check again the role down. The role here should be down on the assert, not the rule. We're going to check this assert. And the test that we're making is we're just saying that eScene.06, number of patients at scene, should be equal to this code here, which would indicate multiple. It's the code for multiple. Okay, so these asserts can be quite simple. We see a lot of state schematron files with very complex asserts, and sometimes they have to be. But this one is very simple because our context can be simple. We just want the eScene section when it's an MCI, and then our test can be simple. When we do have that context, when it is an MCI, then we just want to say that eScene.06 is multiple. And then we've got the text that would be shown if that assertion were to fail. So there's a sample schematron encoding of a rule. All right, as with the NEMSIS XML schema, software developers can use the schematron, the information from the schematron schema to build validation routines into their interface. So software developers might design some validation routines that mimic what is in the schematron schema. So for example, an EMS unit should not be back in service before the call began. So it probably makes sense during data entry to have a rule like that shows up with a message and helps people to fix that bad time early. Other checks might have to wait till later. So the example of number of patients seen at an MCI, maybe the MCI data element was in one place in the data entry screens, and the number of patients at scene was in some other place. And we have to wait till they've filled out both of those, and then we can show a warning on number of patients at scene and say, hey, wait a minute, this can't be single because you had an MCI. So even though the software tries to catch errors as early as it can, the schematron schema is the standard, just like the XML schema is the standard. So when it's time to complete a PCR and it's transformed into XML and it's checked to be well-formed and valid according to the XML schema, then it's also checked against the schematron schema. Whenever an XML document is transferred from one system to another, then the receiving system performs all those checks as well. Again, don't trust the sending system, perform all the checks, make sure you're getting good data. Well, schematron's more flexible than XML schema. So that means in particular that we can do warnings as well as errors. So with XML schema, if it's not well formed or it's not valid, that document has to be entirely rejected by the receiving system. So there's no concept of warnings. Either it's valid or it's not, and we accept it or we reject it. But with schematron, we can designate some rules to just be warnings. And so we're still going to put out the messages about the warnings that were found, but we're still going to accept the document if it only has warnings and no errors. Schematron rules also can be updated more easily. Since the NEMSIS XML schema defines the structure of an XML document, that grammar, then software developers have to reprogram their software whenever the schema is changed. So when we did the critical patch, they had to add a data element. They had to add it to their database, to their UI. They had to add it to their exports, and so on. With Schematron, a state can add rules to their state Schematron file at any time and distribute that out to software developers. In NEMSIS, multiple schematron schemas can be applied to an XML document. So we can have the national schematron schema, then we have a state-specific one. If you operate in multiple states, you may have multiple state schematrons that would be checked. And we can also have project-specific schematron schemas, such as what's published by the Cardiac Arrest Registry to enhance survival. So let's recap what can be done with schematron. Schematron can do everything the XML schema can, but it's generally used to do what the XML schema cannot do. It's particularly good for cross-checking combinations of data in different data elements within a document. It can do warnings as well as errors. It can be updated more easily over time, and multiple Schematron schemas can be applied to an XML document. So what does that look like in NEMSIS validation? Here's the process. Over on the left side, we have an agency's ePCR system where an EMS provider fills out a PCR and that gets saved in the agency's system. At the time of data entry, the system may be showing some errors and warnings to the provider. That's good system design to do that. But once that PCR is finalized, it should be transformed to XML format so that it can be validated using those gold standard schemas. The XML schema, or sorry, XML being well formed, then the XSD, so XML schema, and then schematron. If it is not well formed XML, we stop there. If it is well formed, we move on to the NEMSIS XSD. If it passes validation in the NEMSIS XSD, then we move on to schematron validation. Only then. So that's why I said earlier, if a state has a schematron rule that says that patient care report number is mandatory, that's a completely redundant and useless rule because the XSD already says that patient care report number is mandatory. And if patient care report number is missing, it will fail XSD validation and it won't even do schematron validation, won't even start. But if the first two steps pass, we do schematron validation, which may include both national and state schematron validation for this agency. The agency system will send the data to a state system. The state system will perform all those checks on the data on the way in to the state system. Again, doing it sequentially, only doing schematron validation if XML was well formed and XSD validation passed. And then the state system will send a subset of that record using national elements only to the national system. The national system will validate as well. Is it well-formed XML? Does it conform to the national only XSD? So that's a different XSD. And if so, then we run national schematron validation, but no state level validations at the national level. Okay, so in this final few minutes here, I want to look at how the NEMSIS XML schemas, national schematron schemas, and state schematron schemas show up and are published by the NEMSIS TAC. First, let's look in the NEMSIS data dictionary. The NEMSIS data dictionary is auto-generated from the schemas. The majority of the information in the data dictionary comes from the NEMSIS XML schema or XSD. Everything I've highlighted in this box up here, the name and number of the element, the definition, how many times it can occur, whether it's nillable or has not values or pertinent negatives, if it has a code list, if it has comments, associated performance measures, all of that stuff is all from the XSD. Then you'll see one section at the bottom called associated validation rules. And this will list some of the rule-based validations that apply to this particular data element. And that one section alone comes from the NEMSIS national schematron schema. When you're viewing the data dictionary, you're not going to see any state schematron rules, but you will see the national rules at the bottom of the page in that section there. So again, vast majority of what you see in terms of validating data is all defined in the XSD, the XML schema. But then we've got those rules where we can do those cross-element checks and things like that that can only be done in Schematron. Here's a little snippet from one of the state pages. So if you go to the NEMSIS website, scroll down to the map of the United States and click on a state, you're going to get information about that state, who their data manager is, and so on. And you're going to have a section called NEMSIS 3 implementation tools. And you can toggle different versions that of NEMSIS that the state has published tools for. And these two buttons in particular are the buttons that will get you to the Schematron validation rules that that state has published. One for agency demographic data. Only about 7 states have published validation rules for demographic data. And then the second one for validation rules for patient care report data, and almost every state has published validation rules for PCRs. So those are the state schematron schemas. States are not allowed to publish XML schemas or XSDs. Why? That grammar-based validation, it means software developers have to reprogram their systems when changes are made. And so states only have the ability to publish schematron schemas, the rule-based validation. One additional resource I want to show you here is the National Schematron Library. And I've got a link to the URL there. Or you can go to the NEMSIS website and go to the technical resources menu and find the Schematron library. This is a single location where you can just search and browse all of the national rules and state rules that have been published in the various Schematron schemas. So you can just start typing there and you'll see rules from all over the country related to your search. So there's a few handy ways to get to the rules. All right, well, let's summarize and then I'll open up for any questions that people may have been holding. So the NEMSIS standard is XML based. And a cool thing about XML is that it can be validated. NEMSIS data are validated using 2 schema languages, XML schema or XSD, which does the grammar-based validation. So here's what it should be structured like. Here's what's allowed. And then schematron, which is rule-based validation that can say, hey, if this, then this should be the case, those conditionals. NEMSIS uses schematron to do what the XML schema cannot. So if the XML schema can do it, then it's in the XML schema. And software user interfaces are built using the schemas as references, but at some point they have to export their data and they must validate the data using the schemas provided by the NEMSIS TAC and the states. And when they import data, they need to use those schemas to validate the data. Karin, yeah, go ahead again.
Can you go back one slide, please, Josh?
Yeah.
Now, I know the answer to this, but I'm wondering if there's any plan. So right now, if one looks at other state systems for their schematron rules, it only applies to NEMSIS existing elements. So whether that's in version 3.5.0 or version 3.5.1. Correct?
I think so.
So
Keep going.
my question is, what about custom elements? Is
Got it.
elements only available off of the state data set or the schematron files? I mean, that's what I'd like to have you address as well.
Okay, got it. Yeah, states can define custom elements. Now, as we said, states can't publish XSDs or XML schemas, right? So they can't publish an XSD that says, hey, we do everything that National has, but we also have these 5 additional data elements, and here's their constraints and everything. They can't do that. So what they're allowed to do instead is publish a state data set, which is an XML document itself, and that state data set can have custom element configurations in it. And that tells vendors, okay, we've got some custom data we're collecting in our state. Here's how that data should be structured. When you export the data, it's going to export out in a structure that the national schema has already allowed for, which is the custom results section, and tells software developers how that data should look in the custom results section. So that happens in the state data set where they publish the custom element configuration. Now, the software then would export the data, and there would be some data in that E custom results or D custom results section. And then the question is, well, do we know that the software developer actually did it correctly? It's going to pass the NEMSIS XSD validation, as long as they adhere to certain constraints. They could put anything they want in the custom element results, and it's probably going to pass XSD validation because it's a very wide open section. But does it actually comply with the configuration that the state published in their state data set? If a state wants to enforce validation rules around the custom results data, then they need to put those rules in their state schematron file. So the state data set and the state schematron file will often kind of work hand in hand, where the state data set says, hey, here's our custom elements that we collect. But then on the schematron side, the state can say, okay, let's check the custom element data. And when it's data for, custom 101, whatever we called it in our state, then it needs to be a number, right? Or it needs to be between 1 and 10, or it needs to be one of the codes that we configured in our custom element. Any of that stuff needs to be in the state schematron rules. If the state puts it in their schematron rules, then it will show up in the national schematron library.
So, Josh, and if nobody wants to review this, just say, don't need it, Karen. Feel free to, if you have your, feel free to go to South Dakota's, because we have
Mhm.
a good number, as many people are aware.
Yeah, I'll take a look. Yeah, so I see, quite a few here that you have related to CARES. And this is in your schematron rules.
Correct, but I'm
Yeah.
wondering, but I'm not expecting their custom elements would be there. Correct.
If you created validation rules around the custom elements, then they'll be here.
Oh, they still will be there. Okay.
Hmm.
All
Yeah.
right.
Yeah. Yeah. Thanks for the question.
Thanks, guys.
All right. Yeah, let's open it up for other questions. First, maybe I can get reaction. Uh, if someone asks you what schematron is and maybe also asks you what it's not, do you feel like you'd be able to answer their question? Maybe like a thumbs up or something in Zoom. Getting a few there. Okay, great. Anyone who still feels like, "Nah, I'm not sure I'd be able to answer that question. Do you want to maybe raise your hand or something and maybe we can maybe you can ask for some clarification and we can do some follow-up. Or if you have any other question you want to ask, feel free. Karine.
Yeah, so I'm still learning. So I'm trying to make sure I have this right.
Mhm.
So can a schematron do everything an XML schema can?
It
Is that
can. It would be cumbersome, but it can.
okay? So I guess that would have been my question is like, why do you use both instead of just using a schematron? But I guess that's the cumbersome part.
Yeah, great question. So the XML schema, the grammar-based validation essentially says here's what's possible. And then the schematron validation has rules that say, well, here's the stuff like if this, then this kind of stuff, right? Like those conditionals or things across different data elements or ranges and things. So um, if you were to only use schematron, you'd have a very large schematron file trying to explain everything that is possible in the structure of the data. It would be very complex. Whereas the XML schema or XSD, because it's designed for grammar validation, it's just really good at that. It's really good at saying, here's a data element, here's how many times it should happen. Here's its data type. Here's the list of potential answers that could be provided. Here's a definition, some additional comments. That just goes really well in XML schema. So it's essentially leveraging XML schema or XSD to do what it does really well already, and then only using schematron for the stuff that we just can't do in XSD. And I would also say, then for states to be able to set state rules or state level validation constraints, then Schematron gives us that ability to kind of layer those Schematron files where you can check national plus state plus whatever else. All right, are there some
So
other
Josh,
questions?
I had a question on here, and I'm not even sure this is a good question or not. But you said before that any you can use any XML validator to validate your XML. Do you have a recommend or a favorite that you like to use?
I would say I use Microsoft Visual Studio Code a lot. It's pretty lightweight, and then you can install the extensions you need. So that'd probably be my first recommendation for anyone, kind of sitting in their office with a Windows computer. Um, for anyone who's doing programming, they might be using Eclipse or NetBeans or some of those integrated development environments, and those would all have XSD validation built into them as well.
Awesome. Eclipse taking me back to my intro to computer programming class in my undergraduate. So yeah.
All right.
Awesome. Okay, I think looks like there's no more questions here, so I appreciate your time and your knowledge and your willingness to share all of this with us. Great reaction from everybody when you asked for thumbs up when they're understanding. Lots of the fireworks that show up when everybody's doing their thumbs up. So the great thing about this is that. Everything that you explain here makes so much perfect sense as you're explaining it. And then when you go to look at it, you sit there and say, what did Josh say about this before? This is recorded. You can go back to those aha moments anytime that you want. And you can also replay this back, play it at half speed or double speed, however you want. So this knowledge is kept on our YouTube channel. It'll be up by Friday. So if you want to review this information or share it with a colleague, someone new comes on board that's going to be helping you out with this, is a perfect video to get them on board with this fairly complicated, but once you understand it, easier to understand because Josh does such a great job explaining it subject. Awesome. So thank you for the presentation here. If I can get a big virtual round of applause from everybody again, that would be great. We do these every month, and so if you keep track of these through our mailing list or through conversations with us when we have this, I know that the whole team puts a lot of work into putting these together. So thanks everybody who helps out behind the scenes and makes these go. I know that Monet puts a lot of effort into making these go, and she is the point person for actually like coordinating the subject matter on these trainings. So if you have a suggestion or or something, even something you'd like to speak on, let's get go. The best way to get in touch with us about anything is to always open a help desk ticket on nemsis.org. We love ideas, we love feedback. We'd love to hear from you of like even if it's a previous training you'd like again or updated or a new one that you haven't had yet or feel would be useful to you, please let us know. You can interact with us, like I said before, on most social media platforms where you can find out the latest goings on at the NEMSIS TAC. And so thank you so much for this whole year of showing up to these trainings and participating. We look forward to having another great round of these in 2026. Thank you, Josh, and thanks everybody. Hope that you have a great rest of your day and a great holiday.
Thanks, everyone.